Hello and welcome to today's session. As only one participant has joined yet, so let's wait for 5 more minutes for other people to join and then we can start. It's 5 minutes now. I think we should start the session. Quite a few people have joined also. Welcome to today's session. Today we are discussing assignment of week 4. So this is the assignment which was assigned in the previous runs, and we'll be solving questions from that set, so that you can find out how to go about solving the questions, how to use the study material or the lectures which are provided to you to solve the questions which you are assigned with. So I'll be solving the questions from the previous runs. If you have any doubt during the session, you can type your queries in the chat box and I can get to them either during the session or at the end of the session. I hope I'm audible. Can anyone just indicate if you can hear me and also if you can see my screen? Just anyone, if you can just write in the chat box and indicate if I'm audible and my screen is visible. Okay, great. Then let's begin. So, week 4, you would have covered 4 lectures, which are these lectures. We will be solving questions which surround largely these topics. So first you would have covered designing strategically for preventing pollution. So pollution, uh, air pollution, water pollution, soil noise pollution, regarding different things. So in this you would have studied a little bit about air pollutants and how they reside in our atmosphere, what is the average times of their residence, what different impacts they have on the biogeological processes and on human health, and then what risks they pose, how that risk can be assessed. Then you would have studied a little bit about uh, solid waste, solid waste management and pollution occurring due to improper solid waste management practices like plastic, how plastic is uh, how plastic is consumed and the waste of plastic is produced and handled, and things related to plastic production, consumption, and recycling, how pollution related to plastic can be controlled, or what are the pollution reduction techniques associated. Next is low environmental impacts. So in this you would have studied carbon reduction techniques over the total life cycle of any product. Then you would have studied a little bit about life cycle assessment, how you assess the impact that any product's complete life cycle, so starting from its production, then to its consumption and to its disposal and or recycle or reuse, uh, uh, it, uh, how it impacts the environment, that you would have studied. Then you would have studied a little bit about recycling and things like designing for waste reduction, or designing in a way to increase the product's longevity and flexibility, ultimately to make the product have low environmental impact. Then you would have studied a little bit about different pollution sources and how pollution reduction can be done, a little bit about indoor air quality, how that can be managed, or what factors to consider while, or what pollutants to consider while considering indoor air quality. And then you would have also seen uh, several case examples of either low environmental impact building design or product designs such as fabrics, chairs, packaging materials, etc. Then is thinking for alternatives through systemic design. So in this you would have studied two basic thinking processes while design thinking processes, which is one is design thinking and another is systems thinking. You would have studied the differences between the two and how both can be integrated also for design of any product or any service. And then linear and circular processes, how uh, the linear and circular processes can be used for thinking and design process. And then different design thinking principles, as well as systemic design and future thinking also. Last would be consumption and consumerist lifestyle. In this, you would have studied a little bit about global consumption patterns, how it impacts our environment and how it is driven, what are its drivers, a little bit about sustainable consumption, how it can be achieved, a little bit about different business approaches. So this would be innovation, choice influencing, and choice editing, and then some examples of how consumer behavior can be shifted. And then you would also have studied how what is the role that different actors in this situation play. So for example, what is the role of the government or the regulating body, what is the role of the businesses, what is the role of the consumer, and what is the role of other uh, non-profit organizations like NGOs. So this is all that you would have covered this week. So we'll now move on to questions, and we'll start solving them. So first question is, which of the following gases live in atmosphere for centuries? And you are given four options: SO2, CO, CO2 and NO. So this comes from uh, global environment outlook, which is a report which is produced by UNEP. It is a very important report in terms of how in terms of the assessment of environmental health. So in their report number 4, or outlook 4, they produced a schematic which represents for how long different gases live or are there in the atmosphere. So you can see gases like SO2, NO2, NH3, and particulate matter 10. These are the uh, particulate matter is particulate matter. Apart from that, other gases, these only live in the atmosphere for some hours to some days. So SO2, NO2, these are very reactive gases, and they react with other gases present in the atmosphere, and they form different compounds. For example, NO2 and SO2 are they form nitric acid and sulfuric acid, which is a lot of the time responsible for acid rain also. So these are reactive gases which are present in the atmosphere, and they bond with other gases in the atmosphere, and they uh, then convert into different elements. So they only survive for some hours to some days. Then there are other gases which survive for some days to some weeks. So then, like tropospheric ozone, it can survive for some weeks to some months. Carbon monoxide can survive for months to up to a period of 1 year. Then there are gases like CO2, CH4, which is methane, NO2, SF6, HFCs, chlorofluorocarbons, CFCs. These are the gases which are highly stable gases, and it can survive in the atmosphere from uh, years to even to centuries. So this is what they produced in their report. So you can always refer to this schematic, and you can answer uh, these types of questions. So they can ask you which gases survive for centuries or which gases survive for months. So based on that, you can approach this question and solve this question accordingly. So here they are asking which gases live for centuries. So in centuries, you can see SO2 only resides for some hours to some days, so it is not the correct answer. CO, carbon monoxide, it only survives for maximum of an year, so again not correct. CO2, it lies in that time frame, so yes, CO2 would be the correct answer. I hope this question is clear. I've also provided the links of the two documents from which is the source of this schematic. I'd like you to visit this link in your own time and see the documents. I'm showing you just a quick view of the document. So this is the document. You can go to the website and select the language in which you want to download, and you can download the document here. So it will be downloaded in a PDF format, and then you can go through this document. Another link which I have provided, this link is for all the global environment outlook documents which have been produced by the UNEP up until now. So currently they are working on GEO7. The document which we were looking at earlier was GEO4, which contains the particular schematic which we were discussing, but currently UNEP is working on GEO7, so it is under process. The latest report which we have is GEO6. So if you'd like to browse through different reports and different documents, you can go ahead and access the links here. This is a very important document while considering or while learning about environment's health, and it is a flagship report because it fulfills the core function of UNEP, and it dates back to 1972. So since 1972 UNEP has been consistently uh, formulating and publishing this report, and they follow a particular framework in which they make this report. You can go and even see this framework here. So this is the framework which they follow. So they see the drivers of different environmental processes, the pressures which the ecosystem and human health is facing, then the state of the environment, impact of different activities, and the responses that can be taken up uh, in order to um, solve the environmental problems or face the stresses or pressures which are being faced. So for example, this is the GEO4 document which I was telling you. So uh, you can see the contents. So atmosphere, land, water, biodiversity, different aspects of the environment have been discussed, and this is the framework which I just mentioned they use for making this report. So this is the framework. So different drivers, then what are the pressures which are being faced. So then the state of the environment, so state of the natural capital as well as environmental impacts and change, and then what responses to environmental challenges can be there, and then impact. So this is the framework which they follow, and they make these reports after certain periods of time. So you can go to the websites and see this for yourselves as well. Okay, coming back. So I think this question is clear to you, and uh, you can access further resources from here. So moving on ahead to the next question. So the next question asks, as per the World Health Organization's risk assessment process, advice for decision making falls under which step? Okay, so what this question is talking about is the WHO Human Health Risk Assessment Toolkit for Chemical Hazard. So, WHO has estimated that more than 20% of all the global diseases or global burden of diseases, it is linked to environmental factors. So, this can include exposure to toxic uh, chemicals also. So, some example of this exposure can be, for example, lead exposure. It accounts for almost 3% of all the cerebrovascular diseases and 2% of heart disease burden worldwide. and 9% of the global burden of lung cancer is attributed to the exposure to toxic substances, and 5% is attributed to outdoor air pollution. And then even unintentional poisoning is estimated to kill a lot of people each year, and it is majorly happening in developing countries, of which India is a part, and it happens largely due to excessive exposure to toxic chemicals, or if the toxic chemicals are inappropriately used. So the people who are handling the chemicals, or who are in the exposure area of the chemicals, can be unintentionally exposed and poisoned in that way. So, to deal with all of these health risks which are attributed to exposure to toxic chemicals, or even to deal with health risks which are attributed to pollutants in the environment, WHO has created a toolkit which can be followed by uh, decision makers who take decision to mitigate the hazard present, or chemical hazard present in any situation. So what this toolkit does is that it provides its users with guidance to identify, acquire, and use the information that is needed to assess the chemical hazard which is present, uh, how much exposure there is due to the chemical hazard, and then what are the corresponding health risks that can occur in the given context. So it can be on a small scale level, so for a particular factory or a particular area or a particular locality, and then it can even be on the national level. So if there are to be policies for some air pollution or other things which is to be implemented at a national level, even in that case this toolkit can be used. So this toolkit, it provides roadmaps for conducting human health risks assessments, and identifies information that must be gathered to complete the assessment, and provide electronic links to international resources that can be used to obtain information, and methods which are essential for conducting the health risk assessment. So a part of this toolkit is this table, which is the paradigm for risk assessment, including the problem formulation. So these are the different steps, starting from the problem formulation itself, which can be followed by any entity who is conducting the assessment, and using following these steps, uh, the assessment can be conducted, and further uh, responses to any chemical hazards can be planned. So it has several steps. So like problem formulation, hazard identification, hazard characterization, then assessment of the exposure, and then risk characterization. So what the question is asking us is, advice for decision making falls under which step? So you can see advice for decision making here falls under risk characterization. So you know the answer to this question. But apart from that also, you can see the different aspects of each. So for example, problem formulation includes establishing the scope and objective of the assessment. So what problem is there that you need to identify? So for that you have to have the defining question associated to the problem. You have to have some prior knowledge of that problem. So what kind of chemical, what chemical exposure, such things you need to have. And then you need to know the desired outcome. So what desired outcomes you need from that situation, that you need to have. Then for example, hazard identification, for this you need to do human studies or other animal based toxicology studies or IV toxicology studies, in which you need to identify that how the exposure can adversely affect human health. Then hazard characterization can include things like selection of critical data sets, seeing the modes or mechanisms of action, such things. And then exposure assessment can be the magnitude of exposure is there, and then the frequency, so how often it happens, so how frequently or in what way the plan should be formulated. So, and the duration, so for how long the exposure is occurring. Then route and extent, such things are part of exposure. So I hope this is clear to you. I've also added the link to the toolkit. You can follow this link and access the toolkit for yourself. So this is WHO's website, and here you can download the toolkit from this link. So, so this is their toolkit, and you can go into further detail about this. So because what we have discussed so far is just the beginning of how the problem can be assessed and further steps can be taken. So even the different steps, how they can be implemented throughout the process. So this is what we have done. So how each step can be implemented, and what resources to look towards to collect data and prior information about anything. That all is also provided in the toolkit. So if you want to learn a little bit more about that, you can browse this toolkit at your leisure. Okay, coming back, I think this question is quite clear. So advice for decision making, it falls under risk characterization. Okay, moving on to the next question. As per data by WWF, National Geographic, and Our World Data, etc., so several different sources, what is the amount of plastic that ends up in ocean each year in billion pounds? Okay, so actually the data which the WWF, National Geographic, and Our World in data, all of these are science communication channels in a way. So they communicate the environmental science, and they follow certain studies and certain data, and they tell you the amount of plastic that ends up in oceans each year. So most of these study, they follow this most of this communication, they follow this study. So this study is done by Jambek Research Group. So this study is on plastic waste inputs from land to the ocean, and you can access their article here. So this is their article in which they have presented a detailed study of how much plastic is produced by different countries, and you can see the data here, country-wise data also, and how much of this plastic is ends up in landfills, how much plastic ends up in marine systems, everything. So what the question is asking is that how much of the plastic in billion pounds ends up in the ocean each year. So if you look at this graphic, you see that it is mentioned that 8 million metric tons of plastic waste, it goes into the ocean. So 270 million metric tons is the global plastic production, that is what is produced annually. 275 million metric tons is what is produced as the plastic waste. So this is the one which is produced for consumption by the consumers, and this is which is produced as a waste at the end of the life cycle of the product. This is 99.5 million metric tons. This is what ends up on the coasts as coastal plastic waste. 31.9 million metric tons. This is what ends up as coastal mismanaged plastic waste. And then 8 million metric tons is what then ends up going into the ocean. So see here that this figure is given in million metric tons. However, you are being asked in billion pounds. So a simple thing you can do here is you can convert metric ton to pound. So 8 metric ton, so it will be around 17, a little over 17,000 pounds. So 8 metric ton will be around 17,000. So 8 million metric ton will be around 17 into 1,000. So 17 million pounds into 1,000. So 17 million into 1,000 is 17 billion. So a little over not a little, over 17 billion pounds. That is what you get. So seeing the options here, the closest answer would be 18. Another thing, why 18 is the correct option, because this study mentions the plastic that goes in annually, how much plastic goes into the ocean as 8. Some studies say it to be 8.3 million metric tons. So there is some debate on how much plastic is getting into the ocean, and that depends on how the study is done. So which countries are taken into consideration, how the waste or amount of the waste is calculated, such things. So if you want to go into detail how the calculations are done, which countries are taken into account, you follow this study. You can even get the spreadsheet containing all the data, and you can follow and you can see in detail what techniques or what calculation techniques they have used. So I think this answer for this question is clear. Apart from this, I have also added links to the different articles from all these science communication websites which communicate how much plastic is going into the ocean. So for example, this is the Nat Geo's article. So as you can see, okay, I'm not signed in, so I can't access the article further. But you get it. You can access. You can visit this link, sign in and access. Then this is UNESCO's article on plastic waste going into the ocean. So you can see here they have calculated in terms of how many pieces of plastic and microplastics are going in the ocean and other. So you can see different metrics used by different science communication websites. Coming back here, you can see World Wildlife Fund also. So even they have okay, so they have communicated in terms of percentage in PET uh, bottles, how much of that is recycled, how much is going into oceans and everything. So you can see from this that communication of how much plastic is going into ocean is relevant for the specific context. So and it can be measured in different metrics. So it can be measured in metric tons, in billion pounds, in percentages of how much is produced to how much is recycled, how much is going into the ocean, and several other ways. So I hope it is clear to you how many different ways this figure can be communicated and how to calculate the answer for this one. I hope it's clear. So we'll move on to the next question. Next question is, China between the year 2014 to 2019 contributed what percentage of plastic production globally, as per the report published by NPTEL in 2021. So I had a issue with this report. So about the plastic production, I could not find the report by ENTCO, but I found the report by ENTCO on e-waste generation. So you can see here that the report that is published by ENTCO, this is by electronic waste generation, and for this he uh, uh, communicates about different countries. So up until 2019, in metric tons, how much waste has been generated by different countries. So for example, by China, United States, India, and several different countries. And there are even links to, if you want to further study more about this report, you can go into detail. But this question asks us about plastic. So the report which I found about plastic was this report, uh, whose link I have provided here. So what this report tells you is the distribution of global plastic materials production in 2021 only. So you can see China and North America. So contribution of different countries. So if I could not find the specific report by ENTCO, so I cannot tell you, but I hope it is clear to you what this question asks or how to approach the question, which asks you specifically in terms of global production uh, of plastic waste. So I hope that is clear. Moving on to the next question. So next question is, which item as per the National Geographic 2015 report is the most recycled product in the world in terms of plastic? So you are given several options: plastic bottles, pen, plates, and basket. So this is the graphic from that report, which actually tells how easy or difficult it is to recycle certain kinds of plastic. So all plastics are not the same. So the material which is used for making plastics is the plastic is of different kinds. So for example, PET or polyethylene uh, uh, terephthalate, it is used to make beverage bottles, food jars, uh, clothing, carpet fiber, shampoo bottles, mouthwash bottles, etc. Then HDPE, which is high density polyethylene, it is used to make detergent and bleach bottles, snack boxes, milk jugs, toys, buckets, crates, plant pots, garden furniture, trash bins, etc. So these two are the ones which are easy to recycle. So so there are several factors which contribute to ease of recycling. The first is ease of recovery of the material, and then the physical and chemical processes that are involved in the recycling. Then PVC, that is polyvinyl chloride. So it is used in manufacturing items like credit cards, window and door frames, gutters, pipes and fittings, wire and cable sheathing, and synthetic leather. So you see all the items which are being produced, like credit cards, window door frames, gutters, etc. All need structural integrity, or it needs to have a long lifetime. So it is more structurally integral than PET or HDPE. So that is one of the reasons why it is difficult to recycle, because the physical and chemical processes that are involved in recycling are more difficult to perform, or they are more energy intensive. Then there are plastics like LDPE and PP, which is polypropylene. So it is used in LDPE is used in packaging films, shopping bags, bubble wrap, flexible bottles, wire, cable insulation, etc. So this is actually one kind of material in which the machinery required the machinery and processes required to recycle this type of material, it makes it more difficult than recycling PET or HDPE. Then there is polystyrene, so plastic foam, cup, egg boxes, meat trays, packing peanuts, coat hangers. These are kind of materials which are these are the kind of products which are used making polystyrene. And again, even polystyrene is difficult to recycle. Then there is uh, other plastics like nylon fabrics, baby bottles, CDs, medical storage containers, car parts, watercolor bottles, etc. So these are then again very difficult to recycle. So recycling plastic, uh, based on how easy it is to recycle, based on that also it is easy for you to identify that plastic bottles are the one which will be the most recycled. But even this study indicates that plastic bottles are the most widely recycled product, and again, because they are easy to recycle, it is understandable that they are the most recycled products. But it is not only uh, that they're easy to recycle, but it's also the push that recycling policies or actual recycling action that takes place. The push is needed from businesses and consumers themselves. So if you want to go study a little bit more about why bottle became such a important uh, material which is recycled so much now, you can go and study this article by National Geographic. It mentions how the plastic bottle, it went from a miracle container to the hated garbage. So a lot of the discourse around plastic bottles and how they're polluting the environment and how they need to be recycled, that also pushed this bar ahead, so that plastic bottles are now the most recycled items in the world. So you can go look at this article if you want to learn a little bit more about that. This is the link to this study, so you can click on to this and go on to National Geographic's website to study a little bit more about this particular report that they have produced on plastic bottles. Another study which I have linked is this study by Zaman and Newman. So recycling plastics, are they waste of the zero waste agenda or toxic waste agenda? So there is several times a lot of debate if recycling is actually zero waste, or is it producing even more emissions, because even the recycling process itself is energy intensive, and it requires a lot of dedicated machinery and energy consumption to recycle uh, the plastic materials. And many a times the end product of this uh, the recycled plastic is not as sturdy or is not as good in quality as the plastic that is produced in the as a new plastic. So in the end, the product itself, it does not have longevity, and it does not it has a shorter life cycle, thus contributing to a higher frequency of waste generation or production of plastic waste. So these are several things which are attributed to the debate around if uh, recycling or recycling the plastic, is it a step towards zero waste, or it is again generating more toxic waste. So if you want to read a little bit more about that, you can go on to this link and study more at your time. Okay, coming back, I hope this answer is clear to you. Plastic bottles are the most recycled product in the world in terms of plastic. Moving on to the next question. What was the share of European Union's transportation sector in GHG emission for the year 2012 as per the reports of European Environment Agency? So this question is asking specifically for the 2012 report. So here are the links which I've shared with you. So this is the link for the 2012 report. As you can see, there are reports for different years. So for 2015, 16, 17, 18 and up until 2022. But this is specifically for 2012. You can see the report which is mentioned here itself. But what they are specifically asking is the GHG emission and share of EU's transportation sector. So you can just go on to the uh, graphics and which can help you see quickly at a glance the emission share. So you can see this shows bar this chart shows pie chart shows different uh, sectors and what their share is. So energy industries, transport, other sectors, manufacturing, agriculture, everything. So this here is energy industry and this here is transport. So what this shows actually is the absolute emission share. So it does not show in percentage, while what you are the options you have been given are in percentages. So what you can do here is you can go to the table and you can calculate the percentage of transportation sector. So you can take this figure from here from the overall, so you can add up emission from all different sectors and then you can calculate the percentage. So I'll show you how you can do that. If you can just I'll share my entire screen for you so that it's visible to you in my Excel sheet. Okay, so this is the data we have. So we'll just copy this and paste it into Excel. I hope everyone can see. And these are the one which are 2012 and the question specifically asks for 2012. So we'll add these numbers. Okay. So we got the total emission and then we'll calculate percentage of uh, transport sector. So this is the transport sector emission. So we calculate the percentage. So here we got it. It's around 17.49. So let's see our options again. So our options do not match. So I must have made an error. I remember calculating it earlier and the answer was coming somewhere around 24.3. So I must have made some mistake in copying and pasting or adding somewhere. But if you see the transport section's percentage in the overall, you will find that 24.3 is the percentage of the GHG emission from the transport sector from the environment from the report produced by European Environment Agency. So I hope that's clear. Then again, you can go to more reports as well. Uh, so, for example, this is the 2012 report, and from here also uh, you can see different tables associated to this report. So specific table for agriculture, for industrial processes, etc. And then you can even go to the latest reports or report from other year if you want. And if you want to make some analysis or some calculations for yourself, that also you can do. Oh, I'm so sorry. I think you missed my screen. So I'll just go back again. Were you able to see the question number 6? If no, I'll go over it again. Should I go over it again? Okay, I'll go over it again. Can you see my screen now? I hope you can see my screen. If anyone can indicate, okay. Okay, you can see my screen. So I'll go over it again. So what this question is asking is the share of EU's transportation sector in GHG emission for the year 2012 as per reports of European Environment Agency. So I have provided you the reports, the links to the reports of European Environment Agency. You can click on to this link and go to the particular report. So for example, here they are asking in the question for 2012. So this is the report for year 2012. So from 1990 to 2012, you can see. So you can go through this report and you can see the specific metrics they are asking for. Another thing which you can do is you can go to this link which presents the interactive graphics of the emissions in short, so at a glance. And that is what we are actually required here. So GHG emissions sector wise for year 2012, which is what this graphic is showing. So there are different sectors like energy industry, transport, other sectors, manufacturing and construction, agriculture, industrial processes, etc. So there are different sectors, and for each sector the GHG emission is given in this. So but what we are asked here is GHG emission in terms of percentage of the total emission. But here you are not given in terms of percentage, you are given here in terms of absolute GHG emission. So what you can do here is you can go to the table and you can copy this data from here, and you can go and paste it into Excel, and then you add up the total. So you add up all the GHG emissions from different sources. So this is the total GHG emission, and then you calculate the percentage specifically for transport. So you calculate the percentage of transport emission compared to the total GHG emission. So there must be some mistake in this calculation, as I said earlier, but if you calculate it correctly, you'll get somewhere around 24.3%. So that is the answer to this question. I hope it is clear to you how you can calculate it. Go to the table, see the emissions from different sectors in 2012, add them all to get the total emission from different sources, and then select transport and calculate the percentage of transport sector to the total emissions. So that will give you the answer to this question. I hope it is clear now. Okay. I'll present the presentation again. Okay, so this question is clear. We move on to the next one. So next question is, which of the following polluting gas is predominantly not found indoors? So you are given four options: radon, carbon dioxide, benzene and toluene, and oxygen. So there can be two ways to identify which is the correct answer. One can be that the gas is not a polluting gas, and another can be that the gas is polluting but is not found indoors. So you can refer this study of indoor air quality for schools, which has been discussed in your lectures. This study tells you what are the polluting gases which are predominantly found indoors, and what negative health impacts they can have on the residents of any that indoor space. And from that you can find out which of these gases are actually pollutant and which are found indoors. So first, the study tells about carbon dioxide. So carbon dioxide is one of the polluting gases, and it hampers cognitive performance. So if there are high concentration of carbon dioxide levels in a school, so because this study is specifically for a school, it is shown to have negative effects on students uh, cognitive abilities. So they perform poorer on tests, as you can see this metric here, which shows that if carbon dioxide is present in a concentration of 2500 ppm as compared to 1000 ppm, uh, the test results of the student having this concentration is poorer than the students having concentration of 1000 ppm. It also shows that a 400 ppm increase in indoor carbon dioxide level, it is associated with a 21% decrease in performance on a cognitive level of students. So you can see from this itself that carbon dioxide is among one of the pollutants, and how it negatively affects the health of residents or occupants of that particular indoor space. The next gas which this study discusses is radon. So what it says is radon is an odorless and invisible but radioactive gas, and it is responsible for about 21,000 lung cancer deaths in the United States. So you see from this also that radon is another polluting gas which is found indoors, and many countries all over the world require schools to test for radon before it is suitable to be occupied by students. Okay. So you can see that more than 70,000 classrooms in the US have had short-term radon levels. So this again shows that not only that radon is a pollutant gas which affects human health negatively, it is also uh, present in indoor environments a lot. And not only it contributes to lung cancer, it also affects the it also has several other detrimental health effects on both the staff and students which are present in that environment. So again, radon wouldn't be an answer, because again radon is a pollutant or polluting gas which is present in indoor environments. Then another gas or other toxic gases which the study talks about is TVOCs. So TVOCs are total volatile organic compounds. So it can occur in array of different elements like paints and varnishes, wax and cosmetics, cleaning products, even in cooking elements. Uh, these also have negative health effects and can irritate, uh, which can vary from minor irritation, even to liver and kidney damage, or they can even be cancer causing to high if high level exposure is there. So, benzene and toluene are also example of organic compounds which are highly volatile when at room temperature. So they again come under this uh, broad category of volatile organic compounds, and again benzene and toluene are detrimental to human health. So again they will be considered polluting gas, and they are found in indoor environment. So only one option is remaining, oxygen, and this also should be very uh, clear, because oxygen is, as you know, oxygen is necessary for humans to breathe, for human respiration. So it is quite clear that oxygen is not a polluting gas, although it is found in indoor environment, but it is not a polluting gas. So the correct answer for this question will be oxygen. If you want to get into more about different pollutants and what effect they have on human health, and how they are detected, how they affect indoor environments, you can go to this study. I have provided the link to the study. You can just click on and go to this study and browse it in your own time. Coming back, we move on to the next question. So this question actually is not related to the course material for this week. So the domains of the environment, this is related to environmental impact assessment, which is covered in week 5. Still, because this question was shared in week 4 of the previous run, I thought I'll just go through with it, explain to you the material behind it. So what the question asks is, what are the domains of environment, and you are given several options: physical, social and economic, then physical, ecological and social, ecological and economic, and then physical, ecological and socio-economic. So there are three key domains of the environment, and within the key domains there are several subdomains. So the three key domains are physical, ecological and socio-economic. So physical, anything which is present around us, which is tangible, visible to us, we can feel it, we can see it, that is the part of the physical environment or the physical domain of the environment. So it has three subdomains: air, water and land. So I think that is quite clear that these are the three components or three domains of which the environment is made up of, and they comprise the physical part of our domain. Then there is ecological part of our domain. So all the natural living organisms or living beings which are present in the physical system, physical with the physical uh, domain, but are living beings. That part consists of the ecological domain of the environment. So it has two further subdomains, which is flora and fauna. So flora is related to all the plant life, and fauna is related to all the animal life that is present in our environment. So that is the ecological domain of our environment. And then comes the socio-economic domain. So within the framework of physical and ecological domain, there are several social, economic and cultural systems which exist. Not only social in terms of humans, there are several social, social groups or social behaviors that is seen in plant and animal life forms as well. So that, and apart from that, economic and cultural domains that pertain specifically to human environments. So then socioeconomics, it refers to another domain of environment, and these three together, physical, socioeconomic and ecological, these form the three domains of the environment which this question is mentioning. Okay, I hope this is clear. So the answer to this will be physical, ecological and socio-economic. Okay, moving on to the next question. Which of the following are not the benefits of environment impact assessment? So this again, as I said, some questions in today's session are from next week. I'll still explain to you. So you are given four options: better compliance with standards, reduced time and cost for approvals, and decreased project acceptance, and savings in capital and operating costs. Okay, so uh, again, pay attention to the question, as I always say, how it is worded. So you are to select the options which are not the benefits of environmental impact assessment. So first, what environmental impact assessment is. So EIA, or environmental impact assessment, it is basically a procedure that is used to ensure that whenever any new development or a particular new development is taking place, you just ensure that whatever impacts that new development will have on the environment, that are fully understood before the development happens, and they are taken into account what all impacts will occur, and then it is uh, tried to make sure that the impact is minimal, or any mitigation of the impact is taken care of by the person who is developing or other people who are regulating the development itself. So that is what environmental impact assessment is. So there are several benefits of environmental impact assessment. First is that the project or the development, whatever development is taking place, it will be environmentally sound and sustainable in design. So why will this happen? This will happen because you are before even developing that project, you are trying to understand what different uh, uh, even before developing the project, you are trying to understand how it will impact the environment, what will be the different impacts, and how uh, uh, the adverse effects can be minimized, and what can be done in order to mitigate the adverse effects. So when a project is designed considering all these factors prior to the development of the project will definitely be more environmentally sound and sustainable in design. Second is it has better compliance with standards. So obviously, most of the time when standards are formulated, it is taken into care that the standards are formulated in a way that the products or development, whatever is being developed, it has minimal impact on the environment, or it is sustainable in nature. So again, when the environmental impacts is assessed prior to development through EIA, the project or whatever product is being produced or developed, it is definitely said to have better compliance with the standards. Then savings in capital and operating costs. This again is true for EIA projects, because with prior assessment of all the things that can affect the environment in the future, and assessment of all the phases of the development of the project, it is taken care of. So when finally the project goes into development and operation state, there is a lot of savings in capital and operating costs, because everything is considered prior to the development itself. Then reduce time and cost for approvals. Then again, this is true because the project is more environmentally sound, it is better compliant with the standards and everything. So then again, and then having the impact assessment report itself, all of these are factors which helps in reducing the time and cost for getting approval for that particular project. Then increased project acceptance. So again, not only the time is reduced, but even the chance of the proposal of the project getting accepted by the relevant authorities or regulatory bodies, that also increase if you have done a proper environmental impact assessment before development of the project. And then better protection of the environment and human health. So if you are considering all the environmental impacts and taking care to reduce them, minimize them, and mitigate them, then obviously uh, uh, there will be better protection of environment and human health in by doing the environmental impact assessment. So now let's go back to the option. So which are not the benefit of EIA. So first option is better compliance with standards. This is a benefit of EIA, so this is not the correct answer. Then reduce time and cost for approval. So this again is a benefit of EIA, so this is not the correct answer. Then decreased project acceptance. Here we discussed that the project acceptance increases as it is better compliant with standards and is environmentally sound and sustainable in design. So the acceptance rate increases. So evidently this is the correct answer for this question. So decreased project acceptance is not one of the benefits of EIA. I hope this is clear. We'll move on to the last question for today. So this question is flooding as an impact falls under which type of scale as per National Academic Press of 2012? Again, this question I think is related to EIA, but as you have not, we are not discussing that today. I'll just show you this. I did not find the I did not find the specific report which this question is mentioning, but I found other reports which talk of environmental impact assessment and which talk of flooding as as an impact. So another thing which you can do is very easy if you want to solve this question, which is what this question is asking: if flooding is a local, spatial, global, or global impact. So it is quite obvious that flooding occurs in a localized area. It is not a global phenomena. So for example, any project or any development can have different type of phenomena. So for example, if it is a coal energy generation plant, it will have a lot of GHG emission, which will further the climate change. So it will further global warming and then climate change. So ultimately, that project has global implications, or the impact of that project will be global as it affects the global climate. Uh, However, flooding is a process which occurs locally. So if as an impact of some development. For example, I can tell you in construction of many dams, some flooding in the local area surrounding uh, the river which is being dammed, or where the dam is being constructed, there is some flooding which occurs. But that flooding occurs in a localized area, not, or it does not affect the environment on a global level. So from that also it is understandable that flooding is a local impact. So that is there. But this question asks specifically for National Academics Press. So I linked the National Academics Press for you to see. So for example, uh, this is a publication from the National Academics Press. So this is scientific review of a draft environmental impact statement, and this is for the oyster company, and for their special use permit. So this is a review of their environmental impact assessment, and you can go and see how the impact assessment has been done, and how it has been studied by uh, the National Academics Press. Another thing, another link which I have shared is for the National Academics Press's website. So because I could not find the specific report which they are asking for, I just linked for you their repository of all the reports that they produce. So they have different sections. So for agriculture, behavioral, social sciences, biographies, and stuff, in which I think the one most relevant to us is environment and environmental studies, because it is uh, uh, in the context of environmental impact assessment. So in your own time you can go and browse this repository, and you can see if you can find the specific report that the question is asking about, because EIA is supposed to be there for next week as well. I'll just leave this one for next week, and I'll try to find the specific report that the document is asking, and if I find it, I'll definitely share it with you. Okay, but apart from that, I think it's clear how this question is to be solved, and what the answer to this question is. Uh, so that is all for today's session. Thank you very much for attending. But I'd also like to add a little bit more. These were the questions. This is coming from the questions which were asked in previous session. So in previous session, a student asked that many a times while energy efficiency or sustainable practices in for energy efficiency are good for environmental health, but they are not very cost effective, and thus the people who are supposed to implement energy efficient techniques or sustainable techniques in their building design or things, they are hesitant in implementing that. So I found two studies which do cost benefit analysis of domestic energy efficiency. So this is a study by uh, J. Peter Clinch and John D. Healy. It studies cost benefit analysis of domestic energy efficiency. You can go, I have provided the link as well. So you can click on and go to the link and see how they have argued, how they have calculated the cost and benefit analysis of uh, changing over to more energy efficient methods. If there is really energy use reduction or even cost reduction when you switch to energy efficient fixtures in domestic use. Such analysis has been done by this study, and if you want to see more, you can see a little bit from this image how cost and energy benefits are perceived over the years. So you can go and take a look at this study. Another study which I have linked is an economic appraisal of energy efficiency in buildings using cost effective assessment. So this again is a study. I have linked this as well. So here's this link. You can just click on and go to this link. So it does the study for on a building level. So on a building level, you can see how this study calculates the costs associated with changing from the conventional to more energy efficient techniques, and is it really cost effective to do that. What they found at the end of their study is that the from their cost benefit analysis is that it is not really affordable at that particular point of time, uh, changing from changing from uh, the conventional methods to more energy efficient methods, but then they identified the areas in which interventions could be made. So for example, subsidizing specific techniques, specific energy uses, technology, and fixtures by the government, so that actually uh, energy efficiency and even cost efficiency can be achieved by the people who are using the particular fixtures. So such kind of calculations and how these calculations are made, and what factors should be considered, uh, this again you can study if you go through these two studies in detail. uh, I hope this is okay. Another question which was asked in previous session, which I could not answer then, was what factors to consider for sustainable uh, Himalayan architecture, or architecture specifically for cold arid desert. So the student asked specifically for Ladakh. So Leh Ladakh has a cold arid desert climate. So I found a study which is actually a dissertation studying the global vernacular framework for passive architectural design in cold arid desert. So I've shared the link to that study for you to go through it. So it's a very good study. It actually gives you a global perspective on how around the globe the vernacular architecture of cold arid deserts is there. So it takes into account numerous case study from all over the globe. So there are case studies from sub-Saharan Africa, from Southwest Asia, from Gobi Desert in Mongolia, then Hindu Kush, Afghanistan, and several more. So these are specifically for tent type of structures. Then for hut type of structures, there are from studies from Australia, Peru, Chile, Tajikistan. Then for dome type of structures is also there, and then for complexes. So a little bit focusing a little bit more on the urban design or the design of uh, uh, the surroundings or neighborhoods, how they are made. So even study from Leh in India is there. So anyone who would like to specifically uh, see a little bit more about sustainable building techniques or vernacular building techniques specific to the climate of cold arid deserts, you can go on ahead and see the study. So for example, you can see all the different, okay, I'm not able to rotate this image, but you can see it maps out in the whole world which are the areas which have this type of climate. So you can see the whole Himalayan region in the India, and then several different parts of the country, which of these which parts of the world has this specific Köppen classification of this type of climate. And then there are numerous case studies on how the global vernacular architecture in all these different parts is being done. So for example, this case studies for tents are from these particular areas, and you can see specific case studies for specific structures, their materials, their building techniques, everything. And then coming down to even the whole valley, so whole living area, or their locality, or their city or small village, how that is developed, that is also. So for example, these are this is a valley in Algeria, so how they are developed. So they are made in a very compact nature to protect from the heat and from the northern winds. So all these details and construction techniques and the tricks which different uh, areas use to have a more sustainable building approach fitting to the climate, that you can follow from this study. I hope this helps whoever asked this in the last session. Okay, thank you very much for sitting through today's session. I'll take questions now. If anyone has any questions pertaining to today's session, please go ahead and ask. You can just type your question in the chat box and let me know. I'll answer your question. Kirti, Sagar, Anchal, Hemant, if you have any questions, please go ahead. Sagar has no questions. Anyone else has any questions? Okay, Hemant and Kirti also doesn't have any question. Anchal, do you have any questions? I think Anchal also doesn't have any questions right now, or maybe she's not able to respond to us. No issues. All the material which I shared in today's session, it will be available to you on the shared drive. You must have the link to the shared drive. It must be sent to you via email or on the Swayam portal itself. There must be a link. All the sessions are recorded as well, so they are recorded and shared on a YouTube channel. The link to all the videos will also be shared with you. So you can go on ahead and share and access all the resources from the shared presentation and the video. If you still have any further questions, please feel free to drop your questions in the uh, forum, and either me or Professor Shivaji can attend to your questions and we can answer your questions. Thank you so much for attending today's session, and I'll see you in the next one.